Here is a series that we want to write a program for. The series is 1 plus 3 plus 5 plus 7 up to n terms, and we'll have to find out the summation of the series and then display it on the console. So here the value of n has to be taken from the user. So for that, first we would prompt the user by writing printf and say enter n, and whatever user enters we would collect it in a variable. So for that we will declare a variable n, and as it is integer, so we'll have to write %d, and we'll have to pass as a second parameter address of the variable n in which we want to collect the user input. So after getting n value of n from user, now we need to calculate the summation of the series. So for that, first we will evaluate the ith term of the series. So what is ith term of the series? So here if you see, the terms of the series follow a pattern. That is, a term is 2 more than its previous term. So 3 is 2 more than 1, 5 is 2 more than 3, 7 is 2 more than 5, so on and so forth. So whenever we see a pattern like this indicates that a certain logic is getting repeated. And to implement repetitive logic, we can use loop. So here we would be using for loop. So I would write for, then as loop variable we would be using say I, and within the loop, as we are first going to evaluate ith term of the series, so there are n terms in the series, right? So starting from 1 to 3 to 5 7, there are n terms. So we want this loop to run for n times. So we would initialize the loop variable with 1, and the stopping condition would be I less than equals to say n, where n is taken from the user, and the increment operation. So here, as we are initializing the loop variable with 1, and the stopping condition is n, I less than equals to n, and I is getting incremented after every iteration by 1, so this loop is going to run for n times, right? And at the starting of each iteration, what we are going to do is, first we want to evaluate the ith term of the series. So when I is equals to 1, the first term of the series is 1. When I is equals to 2, the second term of the series is 3. When I is 3, that means at the third iteration, the third term of the series is 5. At the fourth iteration, I is equals to 4, the fourth term of the series is 7. So what do you see, the relation between ith term of the series and the value of I? When I is 1, term is 1. When I is 2, the term is 3. When I is 3, the term is 5. When I is 4, the term is 7. So if you see, the relation between I value of I and ith term of the series is 2 into I minus 1. Let me write this, and then we will discuss how why I said that the relation between ith term and the value of I is 2 into I minus 1. So I have declared a term variable, and in that we would evaluate the ith term of the series. So as I said, it is 2 into I minus 1. So let us check. When I is equals to 1, 2 into 1 minus 1, that is 1, right? 2 into 1 is 2, minus 1 is 1. So the first term of the series is 1. when I is 2, that is at the second iteration, we want to evaluate second term of the series. So 2 into 2, that is 4 minus 1, that is 3. So 3 is the second term of the series. What about third term? So at the third iteration, I is equals to 3. 2 into 3 minus 1, that is 6 minus 1, that is 5. So the third term of the series is 5. When I is equals to 4, that is at the fourth iteration, 2 into 4 minus 1, that is 8 minus 1. 8 minus 1 is 7. So likewise, at the beginning of every iteration, ith iteration, we are getting the ith term of the series, which is stored in this term variable. So now we'll have to accumulate the value of term into another variable. Let us first declare another variable in which we want to uh, store the summation of the series. So we would initialize this variable with 0, and to accumulate the value of term variable in the sum variable, we'll have to write this statement: sum equals to sum plus term. So what is this statement doing is, it is adding up the current term variable in into the current value of sum variable, and then storing the result back into sum variable. So at the beginning, when at the first iteration, when I is equals to 1, the term variable is 1, and the initial value of sum is 0. So 0 plus 1, that is 1. 1 gets stored into sum variable. In the second iteration, the term is 3, and the term is 3, and the sum has a value of 1, which was previously stored into it. So 1 plus 3 is 4. 4 gets stored in sum variable. In the third iteration, when term is 5, that is third term of the series, and the sum variable's current value is 4. 4 plus 5 is 9. 9 gets stored in sum variable. In the fourth iteration, the term becomes 7, and the current value of sum is 9. 9 plus 7, that is 16. 16 gets stored in sum variable. So likewise this goes on, and at the beginning of every iteration, we are first calculating ith term, and we are accumulating that ith term into this sum variable. Now at the end of this loop, that is when this loop has completed its n iterations in the sum variable, we would get the summation of the whole series up to n terms. So after the for loop, we are just going to print the value of sum into the console. So for that, we would be using printf function, and we can write the summation is colon, then we want to print the value of sum variable, and as sum variable is integer, so we have written this %d as the placeholder. So at the console, this would be printed, and after that %d would be replaced by the value of sum variable. So one thing I want to add here is, I have seen many a times students would write the print statement within the loop. So if you write print statement within the loop, what would be the problem? First problem would be that this print statement would be executed n times, and this is not we want to accomplish. We want to print the summation of the series just once, right? And the second problem is that the sum would contain at the begin at each iteration, the sum would get added up with the ith term. So at the each iteration, at the first iteration it would have 1, in the second iteration it would have 4, in the third iteration it would have 1 plus 4 plus 5, that is 9. So likewise this sum would get added up, and only after n iterations this sum variable would get the summation of the full series. So we do not want to print partial summations on the console. We want the final result, that is summation of the whole series, and that is stored in sum only after n iterations are over. So for that reason, printf has to be outside the for loop and should be put after it, not within it. So keep that in mind. So we are done with the program, and we would see more of different kind of programs using loops and conditional statements and other stuffs in our next sessions. Thank you.